Okay, welcome to the next lesson. We're still working on question 2 of Newton's second law. Newton's law, let's just say Newton's law. So now on this question we can see what we have. Remember, no stories, just marks. So please make sure that you subscribe on the channel so you don't miss the next lesson. So on this question it says that we have a bakkie with a mass of 900 kg. It pulls a trailer with a mass of 150 kg over a level road. So now one thing I need you guys to do is to pause the video, make sure that you work through the problem. Let's see if you will be able to get these questions right, where they want you to draw the free body label, the free body diagram, and also calculating the acceleration of the system for 5 marks. So if you can pause the video, calculate the acceleration and also draw the free body diagram. So let's start with the first one. It says that on the statement we can see what we have, and this is moving where? To west. Because of this arrow we can see that the bakkie is moving to west, and now they say that the engine of the bakkie exerts a force of 8,000 newtons. So this is the F applied. This is my applied force. So now the frictional force of the bakkie, we are given the frictional force of the bakkie. So this is my Fk of the bakkie. Let's call it FKB. And this is my Fk of the trailer. Let's call it FKT. Right. So now we can see that it is 1,800 and 300 newtons respectively. First question, state Newton's law of motion in weights. Please consult your exam guideline to state Newton's law. So now 2.2, draw a label free body diagram for all forces that are acting on the bakkie. So it's very important you know how to draw a label free body diagram. So this is the bakkie. We know that from this bakkie is going to experience what? The Fg, the weight. So we're going to have the weight going down, we're going to have the normal force going up. So this is my Fn. Then what else do we have? The force of tension, which is that force. The force of tension, it will move in that side. So where is this guy going? This guy is going to west. So this is my tensional force, and if this guy goes to west, we're going to have our Fk also pointing to the right. And this is how you are supposed to draw the free body diagram. So if we just draw it correctly here, this is 2.2. We have the force applied to the left. So this is my F applied. Then we have the Fg acting down. This is my Fg, the force of gravitational. Then we have the tensional force. Let's call it tension. Then we also have the frictional force, which is Fk. There's only one force missing, which is the normal force. This is my Fn. You're going to collect 5 marks if you manage to draw everything like that. So now calculate the acceleration of the system, the acceleration that the system experiences. So another 5 marks. Remember we said we don't want to donate the mark that where we have to write the formula down. So this is what you're going to do. The first thing first, when they want you to calculate the acceleration, and first thing, start working with object 1, which is the bakkie. So I'm going to say, I'm going to call that bakkie object of 900 kg because it's given as 900 kg. I'm going to write it down and say, for 900 kg, we need to draw the free body diagram for what? Only the horizontal forces. Let's go and check. The horizontal forces, how many are they? We have 3 forces, 2 in the same direction and 1 in an opposite direction. So we have the applied force going to the left. So let's redraw our free body diagram. So this will be my Fk, which is my kinetic friction, and we're going to have another force moving in that direction, which is my Ft, the tensional force. So the applied force is moving to the left. This is my F applied. So when you have the free body diagram, this is where you're going to use what? Newton's law, and say F net it's equals to ma. So we choose direction. So I always like to take the direction of the motion as positive. So I'm going to take left as positive. So all the forces that are going to the left will be positive. So I need to take my F applied, I need to minus all the forces that are going to the right. Then equate this to ma. So now we just have to substitute what we have. Do we have the applied force? Yes. Do you have the kinetic? Okay, this is my Fk. Do you have the Fk? Yes. Or I think if we say Ft, Fk, maybe this thing will make people to be more confused. Let's just call our tension T so that we can call our frictional Fk. So the tension, we're going to call the tension T. I'm sorry. We're going to call the tension T. So my tension is T, so that I can just minus tension. So now I have the applied force. Remember, the applied force is given as what? 8,000 newtons. This is my applied force. It's given as 8,000 newton. So I'm going to substitute that 8,000 newton here. This will be 8,000 minus Fk. What was the Fk of the Baki? So we are looking for what? Fkb. This is the frictional force. The frictional force of the Baki. The frictional of the Baki. It's given as what? The frictional force is given as 1,800. So we're going to minus this by 1,800 minus the tension. It's equals to the mass. Remember we said what is this for? The 900 kg. The 900 kg block. So it's going to be minus 900 times 8. So now you just have to isolate the tension, but before that let's try to add the like terms. 1,800 minus 8,000, we're going to minus 1,800. This will give us if you put it on the calculator, this should give you 6,200 minus T, which is equal to 908. So let's move the tension to the other side so that it can be positive. What I'm trying to say, take this tension, move it to the other side so that it can be positive T. Take this 900, bring it this side so that it can be 900, negative 908. So now we know that if we say this thing is going to be 6,200, we minus 900A, this is equal to tension. Let's call this guy equation 1. So now we have equation 1. We need to use the other block to create the second equation. It's very important that even on the other block, you draw a free body diagram. So now we need to identify all the forces that are acting on the block for this one. So if this is my trailer, I know that this will be my Fk going to the left, and I'm going to have my tensional force going to the right. So to the left, the Fk is the one going to the right. Remember, the tensional force goes to the right. And if you still remember, we said that left as positive. The tension, I'm sorry, let's say this again. Let's start. The tensional force goes to the left, the Fk to the right, and we take left as positive. So I'm going to bring let's bring down our 150 kg block. Let's draw the free body diagram. We have the kinetic friction and we have the tensional force. So we set left as positive. So we need to take what? We need to take the force of tension. We need to minus the Fk and equate this to ma. We just have to do the substitution. Remember, we know what is the kinetic friction of the 9 kg block. It was given there as what? It was given as 300 newtons. So I'm just going to substitute that and say this is my tensional force minus 300. It's equals to what was the mass of the trailer? It's 150 kg. So I'm going to say this is 150 A. So now the aim is to do what? Remember, this is my equation 2. Equation 2. So now, you know what I'm going to do? I think someone can prefer to substitute equation 1 into equation 2 and say that I already know what is tension. So where there's tension, I'm going to put what? Where there's tension, I'm going to put 6,200 minus 908. Yes, I agree with you on that. You can do it like that. But this is what I prefer. If I've made tension subject of the formula, I'll also prefer to do what? To make tension subject of the formula, because if where there's tension, I put this, sometimes you can make mistakes when it comes to multiplying out the brackets. It's fine. So now, let's say I'll prefer to create equation 2a and write this as tension is equal to 150A. The 300 will go to the other side to be positive 300. Let me call this equation 2a. So that the tension, remember the tension is the same. I can equate these two equations. We can equate equation 2a and what? And equation 1. We can equate them and say that if we equate these two, what do we get? We're going to say, therefore, the tension is equals to tension. So it's like saying equation 1 is equals to equation 2a. So now let's substitute and say this is 6,200 minus 900a. We equate this to what? 150a plus 300. This is the method that I recommend. Why? Because I know that I won't make a mistake when it comes to grouping and adding the like terms. So what I need to do is to bring the 900 to the other side to be positive and to bring the 300 to the other side to be negative. So let's quickly highlight that. We say that the 900 will come to the other side to be positive 900a, and the 300 will come to the other side to be negative 903. And negative 300, I'm very sorry. As you can see, I'm moving fast. So now, if I check this, I have to say 6,200. I'm going to minus 300. Equate this to 150a plus the 900a. So let's quickly fix that. Okay, so this will be 900a. Then we still have that to show that the 300 goes on the other side to be negative 300. So now what I need you to do is to work on your algebra and say 6,200 minus 300. This should give you, when you minus these two, this should give you 5,900. Equate this to 1,058. Divide both sides by 1,050. Divide both sides by 1,050. So that these two guys can cancel and tell us what you get. So if you cancel this, therefore you'll have your acceleration as, so it depends if they say round off to 1 decimal place or if they say round your answer to 2 decimal place. What will be the acceleration? This will give us an acceleration of 5.62. If we round it off to 2 decimal place, this will be 5.62 meters per second. But now, very important, where is this Bakkie traveling to? Everything is going to the left, so the acceleration will also move to the left. They want what? Remember that acceleration is a vector. It has a magnitude and direction. So when you say 5.62 meters per second only. Sometimes you might lose a mark. You might lose a mark. So these are some of the marks. Let me show you the mark that we can allow to donate. Now, this mark, so it's either the one of these two equation, you get mark. You see, so this is simple mark. We know that F net is equal to MA. So by showing that, we take the F applied minus the Fk minus the tension is equal to MA, you get a mark for that. So now the next question says the mass of the trailer is now decreased. The mass of the trailer is now decreased. How will this change the net force and the acceleration of the system? So this one, guys, if you remember that we said F net is equals to MA. So this is 2.4. So to answer 2.4, so if you need to answer 2.4, we're going to use Newton's law of motion. The Newton's law of motion. Remember, how do you state the Newton's law of motion? You did know, if you know the definition, we said that an object continues in the state of rest or uniform unless it is acted by a net force. That's Newton's first law. So Newton's second law, when a net force is applied to an object of mass, is going to accelerate where? In the direction of the net force. So the only thing I'm interested in is that the acceleration is directly proportional to the net force, and the acceleration, we're saying that it's inversely proportional to what? It's inversely proportional to the mass. So I can say acceleration is inversely proportional to the mass. So now, if the acceleration increases, what happens to the mass? The mass will decrease. Now they say that the mass of the trailer is now decreased. What will happen? We are decreasing the mass. If the mass decreases, the acceleration will increase. So the answer for 2.4 is increase. You answer that using Newton's law. This is 2.4. It increased. Why? Because the acceleration is inversely proportional to the mass. Maybe we should also write it down here. The acceleration is inversely proportional. So now an increase in the mass will decrease the acceleration. A decrease in the mass will increase the acceleration. And that's it for this lesson. So now you understand how to collect these 14 marks. So thank you for watching. Please make sure that you subscribe so you don't miss the next lesson.